LetterVis, a letter space view of clinic letters. This presentation is structured as follows: the motivation behind the study, our contributions, related work, a brief description of our data and our evaluation, a demo video of LetterVis, and finally, limitations and future work. Routinely collected patient records, also known as electronic health records, are deemed as valuable assets in answering clinical research questions. From our interviews with neurologists, clinic letters are often stored in a free text format. The writing styles vary between different clinicians, making the job harder for post-analysis. This includes the extraction of critical information. The process is labor-intensive and error-prone. We propose LetterVis, a novel visualization tool to support the analysis of clinic letters, enabling the user to explore letter content and patterns visually. LetterVis provides 5 linked interactive views to present different levels of abstraction. We collaborate with experts in epilepsy and visualize anti-epileptic drug prescription to support their research. The iterative collaboration allows us to collect requirements through interviews and gather feedback along the way, and finally, evaluate our work via case studies that are designed to answer their hypotheses. To the best of our knowledge, there is no investigation for the use of letter space under clinical settings. We believe that the position of numerical data in letter space can provide important clues about the context hidden inside the unstructured text, likewise for prescriptions. Clinicians and EHR analysts are also used to this letter space format that they operate in. We review related work predominantly in these 3 areas. Apart from interviewing domain experts, existing work to visualize and compare EHR data were reviewed to inform our prototype. We also investigate the combination of visualization with NLP and advanced query techniques to support similar tasks. The key difference between our work and previous work is the introduction, development, and evaluation of letter space and its application to clinic letters. Our data includes 200 anonymized real-world clinic letters written by different NHS neurologists specialized in epilepsy. These letters contain information that is crucial for patient treatment and post-analysis. We carefully designed 3 case studies together with domain experts to evaluate our work. The case studies focus on identifying common and unusual AED co-prescriptions, 5 different ways to find outliers, and finally, AEDs.
This is an overview of LetterVis, which consists of 6 different parts. Part A shows the user options for searching, rendering, and sorting. It also contains a color legend for 12 predefined text data categories, which is the default search query performed when letters are uploaded. User-defined search queries can be initiated from the search bar. Query history is shown on the right. Part B shows the matrix view and its color legend. The matrix view shows a co-occurrence matrix specifically for visualizing anti-epileptic drug co-prescriptions. Part C shows the drug chain view and its color legend. In the drug chain view, blocks representing multiple AEDs are linked in order of appearance in the corresponding letter. Part D shows the global view, the highest level of abstraction that shows all search term samples in letter space. Part E shows the thumbnail view, the second level of abstraction. Each juxtaposed thumbnail represents an individual letter. Part F shows the focus view, a summarized version of letters. It contains a detailed view of the letter in focus. Now, let's look into each view in detail. The global view is the first and highest level of abstraction that shows all data samples in letter space, and their corresponding centroids extracted from the dataset in one superimposed letter space. In this case, we click the centroid for measurement. This triggers the rendering of edges to the corresponding individual data samples.
And we could look at the difference in the centroid from that letter to the global picture and say maybe we don't trust this letter. Actually, we might just want to err on the side of caution and maybe just not bring that prescription through on that particular letter. So I think the ways of sort of getting an ideal global picture, and when you add in letters, see how much they deviate from that.
Yeah, that's right, isn't it? Because that's one of the problems, is how big to make your window for when you pick up terms. And this gives you an idea of the distance between two terms, doesn't it?
The thumbnail view is the second level of abstraction. Each juxtaposed thumbnail represents an individual letter. Similar to the global view, a user clicks on a centroid to show each connection to individual samples. We render edges because they convey the area covered by a category of values in letter space. Data samples located further from the centroid often have a higher chance of depicting outliers. We provide 3 rendering options for centroid, individual sample, and edge in both the global and thumbnail views. Focus shows the data in color, context shows the data in grayscale, and hide removes the data samples and edges. The focus view is the third level of abstraction that shows a summarized version of letters. Individual samples are highlighted. Lines without text data of interest are collapsed by default and can be expanded manually while clicking on the arrow glyph. We include a co-occurrence matrix for the exploration of common and unusual anti-epileptic drug co-prescriptions. Popular co-prescriptions are trivially observed when matrix view is sorted by co-occurrence frequency and are rendered in more distinct colors. The matrix view only indicates co-occurrence of pairwise drugs. We click on a matrix cell. The drug chain view is generated. Each chain contains multiple AED blocks that are linked in order of appearance in the corresponding letters. This view aims to provide a visual representation of prescription progression and may unveil unique insight into epilepsy progression.
And the answer's there, but I think it's spotting patterns that you wouldn't see otherwise, isn't it? That's the main thing, which we do all the time. Spotting outliers, that's really good. You might not have thought to think of looking at people who are on the tigabine and pregabalin, which is a very strange combination. I never thought of searching for that, but if I could see in your matrix that's when I think, oh, I'm definitely going to look at that patient.
It looks good.
It does look good. The size is about right as well, isn't it? You can see all the drugs there across the top and the side, which is perfect.
We sort letters by total edge length. In the thumbnail view, letters with centroids sparsely placed often indicate an outlier. We expand the focus view to show the entire letter to confirm the finding. We select lamotrigine due to its popularity in co-prescriptions to align the drug chain view. Letters without the AED are rendered as contacts. We sort the letters by alignment for further filtering. We identify one outlier immediately, letter 1 to 7, as it is the only chain starting with sodium valproate. We sort the letters by the number of AEDs and explore letters on both sides of the sort spectrum. We also observe outliers by color. A rare AED occurrence may indicate an outlier. We can also combine color mapping with sort by gender to identify outliers. A horizontal gray separator separates two genders. We perform a keyword search, pregnant or pregnancy, and drugs.
So that's interesting because, if you get really granular on this, for example, pregnancy and certain drugs. If you can spot from a bird's eye view that in some letters, mentioning things like sodium valproate, which you shouldn't be taking if you're pregnant now, and pregnancy, you would immediately want to read that letter because they're in close proximity. So something's not right. So I can see this being really useful.
A major limitation is the data sample size. We are currently waiting for the NHS to approve the use of a much larger dataset. We also aim to incorporate more advanced NLP approach to automate data extraction. Currently, we use a list of extraction rules supplied by our domain experts to extract fundamental information that they use in their daily research workflow. With advanced NLP techniques, we may potentially reduce the need for human intervention to verify AED co-prescriptions. This work is funded by the grants provided by the Engineering and Physical Sciences Research Council in the UK. Thank you for your attention.